Hi, we're going to look at rational expressions today. Rational meaning, fraction exponents, an expression just problem without an equal sign. So we're going to go back and forth between our rules of exponents and our rules for how to just manipulate fractions. All right, so first, uh, when you have two bases that are the same, they're being multiplied, all we have to do is add those exponents. So even though we have fractions here, we can still just add those exponents. In this case, you're going to get x to the 6th over 7th power. And yeah, it's as simple as that. Does every problem end up that easy? No. So taking a look at the next one, same base, exponents we can just add together, giving us y to the 1 plus 9 is going to give us 10 over 4. And remember, when you're adding fractions, the denominator stays the same. We're only adding those numerators, those numbers up top. Sometimes we can simplify those fractions if that's possible. In this case, 10 over 4, we can break down to 5 over 2. And I mean, that's basically it. But what happens when you have a negative exponent? Well, there's certain things that we're not allowed to have. Number one, we can't have a negative exponent, period. We have to have all positive exponents. So that's something we have to take care of. And no fractions in the denominator, no fractions on the bottom. And if we ended up getting a fraction as an exponent in the bottom, we're going to have to rationalize that denominator, do something to kind of make that fraction exponent disappear. So first off, we got this negative exponent, can't have it. So what do we end up doing? Well, we know when we have a negative exponent, we should turn this into a fraction, take this whole group, and we're going to put it to the bottom of that fraction. So we're going to get c to the 5/6. Okay, but we need a placeholder. So 1. Good. We have no negative exponents. That's great. But we also have a fraction in the bottom, which we're not allowed to have. We got to do something. So we're going to do something called rationalizing the denominator. So in order to rationalize, we're going to multiply by a value of 1. When I multiply by 1, if I multiply anything by 1, then what we originally multiplied by, it doesn't change. We're going to try and change the way it looks. So anything over itself will be a value of 1. Okay, so in theory, it's not going to change the value of our problem. We want to change the way it looks. So as long as I have something over itself. Now, my goal is to get this 5 over 6 to turn to a whole number. Okay, 5 over 6 is close, so let's say 5 over 6 plus what equals a whole number? We'll say 6 over 6 because isn't that 1? Okay, so when I add fractions, I want to put a number right there. What can I add to make that there? Well, let's put a 1. As long as I do something over itself, this has a value of 1. Now, going back to my adding and subtracting rules of exponents, these are the same bases, so I'm going to leave that. I'm going to add my exponents. 5 over 6 plus 1 over 6 gives us 6 over 6, which really is c to the first power. And then up top, 1 times that gives us c to the 1/6. That's fine. Let's bring that over. That's fine. And do I really even need that 1 there? No. We can leave it. And let's think of all those rules that I just said. Do you have only positive exponents? Yes. Do you have any fraction exponents in the denominator? Nope. We got rid of it. We're good. We're solved. Or simplified, rather. It's an ugly answer, but we make all of our rules happy in that aspect. Let's try it again. So negative exponent, don't like. Turn it to a fraction. This whole thing has to move to the bottom. So x to the positive 3/5. We need a placeholder, so you put a 1 up there. I need to multiply by a value of 1. So I'm going to have something over itself. In this case, I want whatever's going to be here to help cancel out that 3 over 5. And not cancel out the whole exponent, but I want it to turn to a whole number. So what's that whole number I want it to be? I want it to be, let's say 5 over 5 in this case. Because we have that denominator of 5, well, what do I have to put on the top of the fraction in order for 3 plus something to equal 5 over 5? Well, we're going to put a 2 there. And now, when we multiply and add and subtract all that stuff up top, x to the 2/5 power over x to the, add your exponents, add those fractions, you're going to get 5 over 5, which is really just 1, an exponent of 1. So x to the first power, and we don't even need that little 1 there, to the x to the 2/5 power. And we have no negative exponents. We have no fraction exponents in the bottom, in the denominator. We're good. And that is rational expressions.